Hey everybody, welcome to this session. I'm going to be introducing the Fuego test system. You've probably never heard of this test system before. That's because we just renamed it a couple weeks ago, and even the predecessor nobody knew about. But it actually is it's an alpha level system, but it's actually mature for how much people know about it. Because it's called Fuego, I don't know if you know, but Fuego is the Spanish word for fire, so we get to use really excellent graphics like that. This is public domain fire. I got this off of the internet with a public domain search. Anyway, so I want to start with an introduction, tell you what Fuego is about, what it can do as a test framework, and then I'll get into the architecture, how you customize the system, a little bit of our vision for the project. So Fuego is the official test framework for the LTSI project. And so it's actually been used to test the kernel for that project for, well, probably for at least a year now. In a nutshell, in very, very simple terms, Fuego consists of Jenkins, plus some abstraction scripts, plus some prepackaged tests, all packaged up in a nice container for you. And so I'm going to talk about each of those and kind of why they're in there and what it brings to the table. So Jenkins, you've probably heard of. It's a continuous integration system. And it's very mature. It was formerly called Hudson, but it was renamed a couple of years ago after kind of an ugly fork. But it handles all of that continuous integration-y type stuff that you want, which means that it handles, launches test jobs based on triggers when you see check-ins or things like that, or other types of triggers like cron jobs, time of day, that type of thing. It shows test results, has a nice user interface, has a big ecosystem of plugins to extend its functionality. There are all kinds of different plugins, I think in the hundreds of plugins for things like email notifications, plotting of results, integration of different source code management systems. Primarily Git is what we're interested in for Linux-based systems. It's kind of too big to describe here in detail, but because we're based on a mature continuous integration system on the front end, it brings us a whole wealth of features. And there are pros and cons to that I'll talk about later. The base interface of Jenkins looks a little bit like this, or of Fuego anyway, looks a little bit like that. I'll expand this in a second. So when you get to the main screen, you have this test history and test selection dashboard. You can see what's been tested recently, what failures and successes you've had. Fuego includes some customizations to Jenkins to support host target configuration specifically. It's geared towards testing embedded systems. And specifically embedded Linux systems, and there are pre-installs pre-installed plugins for certain things like plotting that are part of the Fuego system. This is a kind of a blow-up of that. You can see I was running dbench and drystone for this quick thing. I don't know why the POSIX test suite failed there. Anyway, that's neither here nor there. I wasn't real rigorous on my testing, just to show you what the interface looks like. So in addition to Jenkins, which is kind of the front end and the launcher, behind the scenes we have a set of abstraction scripts. And so what happens is one of our goals is to make it super easy to use Jenkins or Fuego for your project. And so part of that is we wanted you to be able to customize the system just by adding a few shell variables that tell the system how to communicate with your board. And then Fuego provides a bunch of shell functions for command and control. So there are abstractions for putting and getting files on the target, executing commands, rebooting the targets, collecting logs, stuff like that. And so it's not tied to any particular board type or interaction type. It's abstracted away. What happens is that Fuego takes all that information and then generates a custom script that it runs at test time, and then lets that thing run and do what it needs to run the test programs on the target. There's one aspect of this, which is the actual test variables themselves. One of the problems that we encounter in test frameworks is the need, if you're going to be running a test in multiple configurations or on different boards, you need to be able to abstract away certain of the test variables because they're different depending on the distribution you got running on the board or how you've got the board connected in your farm. And so this sounds like not that big of a deal to be able to indirect the test variables, but it actually is one of the core features of the system. And I'll talk a little bit more about it later. In terms of how this is done, we actually use an overlay generation system. There are 4 areas of overlaid functions, or overlaid function variables. We have the actual functions that interact with the target. That's a set of shell scripts. The board definitions, the tool chain variables, and then the test parameters. And then those test parameters go through a level of indirection, which means that you just define a couple of variables at the board level, and then the appropriate variables show up in the environment of the test program, but in a customized way. So all the tests, we're running pretty much pre-built, well, we're running tests that we build, but the kind of the core of the system is a simple shell program wrapper, and I'll show you an example of that. And that wrapper is actually expanded out into a full script with all the capabilities at runtime. So it kind of looks like this. So there's a bunch of Fuego functions that have the communication and the control of the tests. Those are pulled into the test script up there, the orange thing. And then there's a bunch of other things that feed information to the system in terms of a board.conf file. The tools.shell has the information about the platform or the SDK that you're using. And then a test plan and test specs. All of that is generated using a Python program. You don't have to know Python, but under the hoods there's a Python program that generates a single shell called the Prolog shell. I have no idea why it's named Prolog, but then that is the script that will actually run and do a bunch of things to your target to prepare it for the test, to deploy the stuff, the actual test program, and actually execute the test. So the test parameter abstraction is really important, and it's key to how Fuego operates. It's really important to be able to write tests that run in multiple configurations. And so we abstract, obviously, one of the first things you need to do is abstract the target access methods. So if you're running an Android thing, you want to deploy stuff using ADB over USB, usually. Or a lot of our embedded platforms, we abstract, we talk to them with SSH, but you might have limited network capabilities, and so you may actually be putting and getting files over the serial console. All of that is abstracted away, so this test framework and the tests themselves don't need to know all those details. Fuego also abstracts things like the platform for the software builds. So you can, in theory, I have only done Yocto project SDKs and tool chains, but in theory you can stick a build root or a Linaro tool chain in there, and you define some variables, and it all just works. And then Fuego abstracts things like the file system and devices and the mount points for some of the file system tests that we do. So the thing about this is that it's completely flexible. Users can add their own data elements to be abstracted. So when you're creating your own tests for the system, you can make them in a way that will run on multiple boards pretty easily. And there's kind of I'm not going to get into the details of this, but there's a test plan system. So you take a collection of variables and you say, well, this is how I want to run my tests on this board. Or this is the type of testing I want to do with, say, Bonnie or IOBench or something. And that's called a test plan. So a collection of variables together can be passed down to the test scripts and run them in a particular manner. So it also, the third element of Fuego is it comes with a bunch of prepackaged tests. There's over 50 tests already included in the base system. And you can read a bunch of these, IOZone, Bonnie. There's a bunch of file system tests. There's the venerable LTP. Cyclic test is in there for real-time testing. And so there's a lot of different tests you can run, including stress tests. The main 2 categories of tests are functional tests, so basically pass-fail, does this thing work as expected? And then benchmark, is it performing as fast as it's supposed to, essentially where the pass-fail is some kind of level of performance. There are stress tests, and they're actually treated as functional tests. So tests are actually built. So Fuego actually includes test program source code. And you can use your own tool chain to build these tests. There is actually a tool chain included. There's a generic ARM tool chain that's included in the system. And if you happen to be using Yocto project, we actually provide a meta layer that helps you build an SDK that will support all of the tests that are in the system. So you just add this to your open embedded configuration, and then when you build the SDK that matches your image, it'll have the appropriate libraries and headers that are needed for building tests for Fuego. And then the last component of this is all of this stuff is packaged up inside a container. So Fuego actually builds a Docker container, and this avoids a lot of install issues. You probably heard in one of the keynotes today, Mark Scarpness was talking about putting Yocto project in a container, and I can attest. Actually, this is a relatively recent addition to the project. We had I used Fuego. Well, it was under a different name, but I used Fuego before it had this Docker container, and boy, was it a hassle. Things would break, and I was using it on Ubuntu, and it had been written on Debian. Well, now all that should be a thing of the past. If you encounter any issues with this, let us know, because it's supposed to be really seamless. The other thing about being inside a container is that all your builds should be 100% reproducible, because you should be running in the same kind of host environment for doing the builds of your test programs. So a little bit about the architecture. So there are kind of two major parts of this. There's the front end, which is in Jenkins, was kind of the user interface and the launcher for controlling the test deployment. And then you have this script backend. As a developer, when you're writing tests, as you're plugging boards into the system, you need to understand our shell system. The backend is almost exclusively written in shell script. The reason for that is shell is kind of a lowest common denominator language. We didn't want to impose, I don't know, C++ or Java or something else on you. So the main interface between Jenkins and the test programs themselves is this glue layer that's in shell script. There are a couple of very small files required for some other things. There actually is a little tiny snippet in Python, but it's only like about 20 lines long. You'll figure it out. Python's pretty easy. And that's used for log parsing, just because of regular expression handling, and then for some of the results plotting. So this is kind of an architecture diagram. So the yellow thing is that host machine. You want to test a target board, that orange thing. And then as part of Fuego, we are not at the point right now where you can download the Docker images, but right now what you do is you build one when you first install Fuego. And so there's a container build system that we provide you. That generates a Docker container, which is where basically all of the stuff runs. And so inside that Docker container, you have Jenkins, you have the test programs, the scripts that are controlling all of it. And one thing that's interesting to note is there's actually a volume mount out to the host file system where persistent data is kept. So you don't actually want to install a bunch of tool chains and stuff inside your container. Well, it looks like they're in your container, but they're actually on the host file system. They're kind of largish. Usually an SDK runs in maybe a gig or two. And then you have your configuration, which you want to be persistent. All your build data and your logs is actually out in the host file system. And so it keeps the container a little bit lighter and makes it so that it's persistent. So if you need to upgrade the container, we make some changes to Fuego, all your data still persists. And then there's the web control interface. Notice that it kind of goes outside that yellow box. The most common use case is you're running a web interface on localhost just to look at the web server running locally. But of course, because it's a web interface, you can then expose that to the rest of your organization, or even publicly if you're brave, and let people run tests on your board, or look at the test data. Oh, let's see. Oops. OK. So how do you get this? How is it deployed? It's deployed as 2 Git repositories. So there's a main Fuego repository. This is the main one. Well, I'll just say this is what you get if you want to get started working with Fuego. This is the stuff outside the container. So it contains the information about the the container build system, and that includes some Jenkins plugins that have been customized. It also has a default config and some boards, and it has the host scripts for controlling containers. So basically all the stuff that kind of helps you set up the container is in there, along with some documentation. And then the Fuego core repository is the stuff inside the container. And it's divided into those two sections to keep them separate, but also because what happens is when we build the container, we actually do a git clone into the container of that core repository. And so if you need to update the tests or update the Fuego system itself, you can pull those directly into the container. And this has the scripts and the overlay engine, the prepackaged tests, and some more Jenkins extension stuff. And then, as I said, Fuego core is downloaded for you during the container image build. So theoretically, you never actually have to git clone that manually yourself. If you do, then something's gone wrong. What you download is just Fuego. Well, I'll show you. I think I have the steps here. Yeah, so you do a git clone of fuego.git off of Bitbucket. You cd to that directly and run the install script, and that will build you this really neat Docker container. And that takes a little while. It's the image inside the Docker container is a Debian image. But then you build the image, create the container for it, and then start it. And then you can go use your browser. I have Firefox here, but of course you can use Chrome or Lynx. I don't know if Lynx would work. And then if you want to get access to the container, well, when you start it up, you'll get a shell prompt in the terminal window where you start it up. But if you want to start additional shells so that you can monitor what's going on inside the container, you can do that. And there's actually an SSH daemon that's running inside there as well, so you can access that. That is configurable. So again, theoretically, you can access this thing from anywhere. So once you have your Docker container running, you can come in on the port 2222 and access it from anywhere in your organization or the world. I suppose that would make it a thing on the internet. So this is what it looks like. And this is a list of, this is the history. The very first thing you see when you get into the system is you see this history. There's a couple of tabs there. And you can actually go in if you want to run and manually run a test. You could just select a test from the list. You select the target that you're going to run the test on. Select a test plan, which is kind of that set of configuration variables. And then you just push run the test. And it should just all go. This is ignoring, of course, the actually more difficult thing, which is setting up so that you've got a connection to your board. Depending on what test you're running, the board may need to reboot. You may need to deploy new kernels to it. And there's support for some of those operations built into the system. But every board has kind of different, well, every person who sets up a board has kind of different physical things they do. Some people are using relays, web-based relays to reboot their targets. I happen to be using a USB board that allows me to do power control and console control and stuff like that. So how you get to the console, how you get to how you reboot the board, those types of things are physical things that need to be done to get set up for a test. So this is a list. If you were to click on the tab for benchmarks, you'd see this list of benchmarks, and it gives you Dbench and Drystone were running just fine on my BeagleBone Black running a Pokey SDK. So they have this nice sunshiny thing. These are the types of things when you use a mature continuous integration. You get things like clouds and sun rays when things are to tell you what's going on. An individual test page kind of looks like this. This one was just barely started. Actually, April 3rd. Yeah, that was on Sunday afternoon. I was running a test just to get this screenshot. And you can actually, one of the things that's nice about Jenkins is you can actually watch. It has a system to allow you to watch the console log as the console log comes up. So you can be seeing what's going on and if something goes wrong. So how do you customize this system? Well, there's really kind of three things you're going to do in terms of customization. You're going to add your own boards to the system so you can run tests on them. You may be adding your own tool chain to match the operating system or the stack that you've got on that board. And then, of course, we'd love to see people add tests. And you can run your own tests. You don't have to share them. but we would be really pleased if everybody who used this system and started writing tests shared them so we could build up an ecosystem of tests. So to add a board, it's pretty simple, actually. You add a board file, and then you add a new target inside the Jenkins interface. Again, because there's kind of that two things. There's the front end, which is Jenkins, and you have the back end, which is the scripts. With a lot of these operations, you add a little script magic, and then you have to go into Jenkins and kind of glue that script into the Jenkins framework. And that's what happens here. So the board file for a new board is actually pretty small. It's a shell script with just a few variables that describe the board file. You create it in user data /conf/boards, and that is actually visible outside the Jenkins container or the Fuego container. You give it a target name .board. You define the address, IP address, SSH port, some file system info, and some other things. And then one of the most important variables you put in there is the platform. And that is kind of the key that's used to associate this board with which SDK you want to use. And you can actually, if it's flexible, so you can actually define multiple board. You can take the same board, and if you have different file systems that you run on it, you can modify that and have multiple boards appear in the farm, although that's a little bit dangerous from a concurrency standpoint. But so this is actual one that's in there, which is a QEMU platform. It shows that when QEMU is booted, it has an IP address of 172.17.01, SSH port of 5555, and a bunch of other information, which is pretty much the same for all platforms. The Fuego home is where Fuego is actually going to place the scripts and the compiled programs to run. And then there's a couple of things. If you happen to do file system testing, you provide some variables to say, well, where are the file systems mounted, and that type of thing. So really, when you do this, you usually copy an existing board file, and you edit 2 or 3 variables, and you're done, in the most simple case. Excuse me. So, and then once you've defined that board file, you go add the target to Jenkins. So you go to the target status window, you select new node, you go and you copy, there's a template node in there, you copy something called template dev, and then you set the board overlay, there's an environment variable, you set that to refer to that file you just created. So it's not a lot of steps. Basically, the only variable, this is for a fictional Blueberry Pi board. The only thing really that I had to change on this was the name, that top line, and then down here the board overlay just pointed it at board/bluepi.board. I don't know if you can see that, but so it's pretty easy to install a new board in the system. And that's in general, we want things to be as easy as possible to set up a board farm or to test an individual board. Adding a tool chain is kind of a similar level of difficulty. The most difficult thing about adding a tool chain is getting the SDK for the tool chain. That is way harder than installing it, although it's a little bit tricky because we're inside a container. So the main 3 steps are you obtain or build your SDK, and then to use it from inside the container, you have to install it inside the container so that all the paths are right. And then you just modify a script inside tools.shell. And so the steps go like this. You would, if you happen to be using Yocto, you'd bitbake using whatever image name you're using to -c populate SDK. That will, go off for 2 hours, make yourself a sandwich. Well, if you've built it before, it doesn't take that long. But the first build on Yocto is pretty long. Then you just use Docker PS to get the container ID. Use that container ID, copy that thing. The SDKs in Yocto show up under temp deploy SDK, and they actually are a single shell file that it's complicated, but it's a single shell file that has all the entire SDK built into it, and it's self-extracting. So you just Docker copy that into the container, and then inside the container, you just run that shell. And I use dots and wildcards to avoid typing the super long names that you have on those types of things. And then what you want to do, you don't have to, but it's highly recommended that you install the tool chains in a specific place under user data tool chains. just to keep everybody sane. So I did this just the other day, did it under user data toolchains Pokey 2.0.1. And then again, because you've got this kind of dual mode thing, you have to tell Fuego about that SDK. So you have to add the entry for that new SDK you just installed in tools.shell. You have to decide on a name you're going to use for it. On mine, I called it Pokey SDK. And then you go to the tools.shell file, add some environment variables again that tell you where it's at. In the case of a Yocto project SDK, you actually only have to add one, maybe it's two environment variables. And then you just source the environment script that Yocto creates, and it sets up all the other environment variables for you. So it's supposed to be super, super easy to do. It's kind of complicated. It looks complicated, but when you get into it, it's actually not too hard. And then to use that platform, you set that environment variable in the board for whatever boards are using that image. Finally, how do you add a test? So the Fuego tests consists of the actual test program, something like Bonnie or IOZone or something like that. And that is shipped as source as part of Fuego. And then also there's the test shell script, which I talked about earlier, that turns into this overlaid thing. And then if you're doing a benchmark, only if you're doing a benchmark, you have a couple of additional files that parse the log and do a regular expression evaluator to determine if you've passed or failed on your performance. And then, again, you go into Jenkins. Once you define all that stuff, then you go into Jenkins and you add it to the front-end system. So the test can be one of either a functional or a benchmark test. And so functional tests, basically the definition there is it's for detecting regressions. It's either pass-fail. Stress tests are defined as functional tests. Benchmark tests just have a little bit of extra logic to them, and it allows you to plot the data so you can see you expect to have not just a single pass-fail, but some value in a range that tells you what's happening with the performance as changes are made to your code base. And so for that, there's a specification file for the data name and the threshold to indicate a pass-fail on the performance. So the test program is usually some pre-existing compiled test program. It doesn't have to be. There are a couple of tests actually in the system that just put a shell script on the target and it collects some proc data and runs some stuff on sysfs. But most of the time you're talking about a compiled program. The source and patches are shipped, and then they're cross-compiled by Fuego for each target. The test script, basically, it's actually pretty short. It's actually shorter than the board file. Well, it might be longer than the board file. I may be lying. But what the shell script does is in just a few lines of shell script, it says how to build the test program, how to deploy it to target, how to execute it on the target and collect the results, and then how to test for success or failure. That sounds like a lot, but most of our scripts end up being under 30 or 40 lines long because we provide a bunch of functions under the hoods that you can call. And so what you do is usually you define 3 to 4 functions in your test script, and then you include the Fuego engine script, and that Fuego engine then causes a bunch of magic to happen behind the scenes. So some of the operations that are available to you in your functions that you define are putting and getting to transfer files to and from the target, command to execute command on the target, report to execute command, and then pull the log results back, and then log compare to check the log for patterns. And then we have a couple of routines. There's actually more functions, but these almost, I would say like at least 50 to 60% of the tests only use these functions and work fine. The other two that are on here is if you're doing file system tests, there's a step in your testing where you want to actually mount the file system you're testing or make sure it's mounted and then unmount it when you're done. And Fuego has built in a bunch of stuff that grabs data and logs from the target and subtracts those out so that you can see just the part you're interested in, and also saves information about the state of the system. So here's an example. This is actually one of the scripts in there. I simplified it a little bit, but not much. And so you define a test build function, which is going to be a make. And at the end of it, there should be a file at the top of the build directory called test suite ready. So if make works, then we touch that file. Otherwise, we do a build error. To deploy it, this particular test is a very, very simple test. It consists of one file called sync test. It's a C program compiled on the host inside the container. And then to deploy it, we just put sync test over onto the target, Fuego home, fuego.tester. And then we use something called assert define. We check to make sure that there's some variables needed for the test, that those are defined in the system somewhere. And then we mount prepare, which is that performs the actual mount of the file system. And then the main action is right there, that middle line there, report. And whatever's between those quotes, in this case, it's going to CD to the mount point. It's going to run sync test is right there. Sorry, I would point at this, but I don't think you can see it. So you should never shine a laser at your own eyes, by the way. Anyway, and then passes some parameters. And then at the end, it unmounts the file system, and that's it. This is actually kind of longer than most test runs look like. Most of them are single lines that just say, report what happens when I do this. And then at the end, the test processing function is used to, the log compare function will scan the log for a specific expression or string, and if it's there, it will report pass or fail. And then the bottom one is that source line that I was talking about to include the engine code into the script. That's the entire script. So notice it's not executable. The Fuego system will execute it for you. I think it actually sources it, but anyway. So in the case, when you're doing benchmarks, there's a couple extra steps just to give you some extra features for benchmarks. So there's a parser.py file that you write. This file extracts data from the log using a regular expression and formats it into a Python map, which it hands back to the system, and the system keeps track of that data as each test is run. It's able to use that to extract data from the log and put it into a little data file. And then you specify also in a separate file, an expression for the benchmark threshold for pass-fail. That is in a file called reference.log for every test. And then finally, again, you have to tell Fuego about this stuff, or you have to tell the Jenkins front end. And so you put an entry in something called test.info that tells it what was the name of the variable that you pulled out, and that's basically it. It associates those variable names with the test. And you end up with something like this. So this is dbench running on a board. I'm not sure what happened on dbench. I wouldn't have expected dbench to fail, but something happened. I was trying to do too much stuff at once, I think, and dbench failed completely on run 9. But so you get these nice plots, and they're basically for free. It's not too bad when all you had to do was write maybe 3 or 4 lines of Python and a couple of lines of shell script. So what is the vision of Fuego? Why are we doing this? It's a neat system. It's got a lot of great capabilities, but we are thinking bigger and longer term. We really, really, really want to address quick and easy setup. People have been doing custom test frameworks in embedded for forever, right? Everybody's got their own little custom thing. And we'd like to actually get people collaborating on tests. We want to support a wide variety of configurations and build systems. So I'm you see that we already have integration with Yocto project, pretty good integration. We could improve that even some more, so it's seamless when you create an SDK to install it into the system. We'd like to do the same thing with Buildroot and any other build systems to make it super, super easy for developers. Just get a Docker container, do the physical setup on their board, and then start running tests. We also want to support a wide variety of target types. Right now, we have support in there for SSH. The serial support is stubbed in, but there's a couple pieces missing. ADB is, there's some patches in the wings waiting to go in for ADB. There's something called TTC, which we use at Sony, which I already have working, but no one here cares about that. And then one of our long-term goals is, just like kernel CI, we'd like to be able to send this stuff to a centralized repository so that we can see the results of testing on multiple different platforms. That really doesn't make sense until we're doing stuff like testing at top of tree. Right now, this is pretty much configured for your day-to-day continuous integration testing on whatever platform you already had. For a lot of embedded developers, that's not top of tree. And we recognize that. So this is kind of longer-term goal. But we want to make it possible for anyone to join a decentralized test network, so that as new tests, as people write new tests, they can just put them into the Fuego repository. You can automatically pull those, and week after week, you see new tests show up. You get to test new things. You're happy. Everybody's better off. It would be nice to solve. One of the great things would be, this is really long-term vision, if you had Fuego installed and a developer knew you had a piece of hardware, you had a problem on a piece of hardware, you could say, well, I don't know, what data should I get, or what should I be testing to see what's wrong with my system? They could write something, you could import it, run the test, and send them the results back, which would be neat. You could do that if there was kind of industry-wide collaboration on a unified test thing. That is it. Although that's our really, really super long-term vision. Okay, so what are some of the next steps? The Jenkins, if you've ever used it, it's a little bit like driving a 747. It is like, it's got so much junk in there. So we want to declutter the Jenkins front end some. I don't know if this is even possible. I'm not a Jenkins expert, but if we could take out all this stuff, there's stuff about Maven. I don't even know what Maven is. Jenkins is a Java-based system. It's got all this Java junk in it. I don't want to see that. So we need to improve the documentation. What we've got there works, but you got to pay attention. It's pretty sparse. It can be improved. Want to do a little bit better at handling USB-type connections, specifically for ADB-based targets. Sony has just recently open-sourced a hardware project that we did for a Sony debug board. We want to make sure we have the integration for that in there if people want to use that. And then, of course, we want more tests. One of the first things we want to do is K-self tests. We'd like to see if there's a way to integrate the kernel CI stuff. It would be super cool if you could download the Fuego project and it included all of the stuff to run kernel CI just out of the box. So download a container, and you immediately you've got a board farm for kernel CI. That would be super cool. Have no idea how to do that. So that's why it's on the second page of my next steps. And then we're looking for a vertical to build out the test suite. So we actually, we know what kinds of things we're using in the LTSI project, but if you have something you think is an interesting area of testing, come talk to us. We might do some of this work for you just because we want to build out the system and try to get it working. And then again, send results to a centralized repository. So you may be wondering, Sarah, the obligatory pointer to resources. So elinux.org has resources. These are brand new pages. Some of them were created last night. But that is why we come to conferences, some of us, because it puts a hard deadline on us. Right? So anyway, the bird.org Fuego, that's my personal wiki, yes. And that's under construction. Don't look at that one yet. I'm hoping by the time you get home and look at these slides, there'll actually be some good material there. Right now, we're using the LTSI dev mailing list. I'm hoping that we'll get enough traffic that it'll make sense to start our own Fuego developer list, but we'll see. So why Fuego? Well, the former name was JTA, which stood for Jenkins-based test automation, which is not a very good name. Let's face it. It's a three-letter acronym, not very pronounceable. So here's the rationale for why Fuego. So there's a place in South America where penguins live. That's Tierra del Fuego. Okay, so there's a little penguin connection there for you Linux enthusiasts. Fuego equals fire in Spanish. Fire is often associated with purifying things, and and plus it sounds really neat. If you name your product Fuego, not only can you have good branding, but you can do stuff like this. It's hot. Come check it out. We'd love to have you get involved and come play with Fuego, which means come play with fire. Isn't that great? Okay, anyway, that's it. Thanks, and I'll take any questions that you have. Yeah? I'm sorry, could you? I do not know how it relates to Yocto tests, so I would guess not at all, given that my complete ignorance of that. So, anyway, yeah. Yeah, back there.
I recently started using the open embedded QA framework, so it's a bunch of Python scripts.
Okay.
And then it will actually, right now I'm on an older version of Hockey, so it just runs on a QE and the latest version that I think will send commands to a target board. So
Okay.
it sounds similar to Fuego. I don't know if you were aware of that or if you're going to integrate with any of
Okay, so I'll repeat the question. The question was about OEQA, is that right?
Yeah, there's a folder called live OEQA.
Okay, so the Open Embedded project has some QA scripts that can run on, right now, an emulator and theoretically run also deploy to a real target hardware. No, we did not. I did not know about that. The CE workgroup in the Linux Foundation actually started this project about 2 years ago. And we did a survey of the existing test frameworks at the time. And yes, Lava existed at the time, but it was pretty sad. Well, I'm sorry. I hope there's no Lava developers. I found it quite difficult to use, and the contractor that we hired to do this found it quite difficult to use. And so we actually kind of went our own way. Of course, it's not invented here syndrome. It's quite possible that Lava or other frameworks have developed in the meantime since we've been kind of working away on this that are comparable. So it's probably a good time for us to look around and see if there's synergies or if there's features we can grab and try to compete with you on, whatever. But that's my answer to that. I'm not familiar with the OEQA stuff. Okay, sounds good. Okay, there was one down here, yeah.
So my understanding again, does Fuego also handle the case of deploying a new large image kernel root processor, or is this out of scope?
Okay, it's in scope in our vision. So there is a deploy phase. There's a pretest phase, and the way the overlay system is written, you can sub in whatever you want in that phase. And in fact, with the TTC system, which is Sony's target control system, we actually have the ability to install new kernels, but those patches have not made it up yet. So we would like to do that. There are extra challenges when you deploy a new kernel and a new image. But we think we're in pretty good shape to support that in the near future. So that was a song and dance, but no, the answer is no. So there was a question over here, yeah. I don't know the answer to that. I was actually surprised when the contractor put it on Bitbucket. I don't know why they did that instead of GitHub. There doesn't seem to be any, well, I don't know, unless you're like a GitHub employee, to a user it doesn't, do you know the answer to that? Yeah. Okay. Oh, by the way, for the record, the question was, why isn't this on GitHub? Why is it on Bitbucket?
In the GitHub bucket, there are huge binary disk space.
Oh.
More than 100 megabytes.
Oh, okay.
That's why.
Okay. Okay, so yeah, so the answer apparently is that Bitbucket allows us to put abusive binary sizes up. Okay, and GitHub won't. Yeah, one back there.
I think it was related to the question up front, but when a test starts, is there an assumption of the state of the target hardware?
There is some. There are some pre-test things that operate on the target. So we do some things, especially for the file system tests, we do things like clearing the caches and perform some other operations to kind of get the machine to a particular state. But not everything. We don't like reboot from scratch every test. So there could be residual stuff, effects lying around from previous tests, but for the most part, we try to make the system pristine for each test. So that's kind of a half answer. We do some things to make sure the test environment is clean each time, but it's not as thorough as going all the way to a full boot. Yeah.
Can you start from like a dead SD card? You know, like a completely blank board. When your test starts, you get it to go.
Hypothetically, yes, because the system is so dang flexible, but we have not done that ourselves. So.
You mentioned this vision of the decentralized testing framework. And also, like, how do I integrate my new board to this testing framework? And also, some reports need to be powered, right? So, is there any plan to standardize this? Like, how can I remotely turn on and off the board?
Well, we would love it if the industry standard became Sony's debug board, which is, by the way, great and has some really neat features. But we don't think it's very realistic in the short term, or pretty much in the long term, really. There's not going to be any single way that people configure their boards. When you set up a board farm, you always have to worry about three things. You worry about the serial console, you have to put your power control in, and you do some kind of networking. And depending on the type of testing, you don't need networking, but you definitely got to have power control. You got to have the serial console. And so Fuego counts on that being abstracted, that you have some method to do that on your board. And then that control can be put in pretty easily. So because Fuego knows, that it may need to reboot a board, and it calls ov_reboot or something like that. And if you need to override that for your specific board, you can. You can write your own function for doing it. So. Well, actually, no. I was talking to Kevin yesterday. It would be super cool if you could download the image. Again, I'm familiar with the Sony debug board, so that's my go-to thing. But just buy the Sony debug board and say, okay, put these connectors here, and you're done. That would be really, really cool. And if we had an industry standard, that would be great. But the Bay Libre folks might not be so excited about that because they've got their own solution for that. But there are not that many solutions. Everybody's doing this ad hoc, right? It's kind of annoying. I'm doing it ad hoc for some of my boards. I've got a web relay thing for power control for some of them. Anyway, yeah. I'm sorry, Sagan? So you theoretically, because a lot of the stuff, the magic is happening in these shell scripts, you theoretically could replace the front end, although some of the shell script stuff has to do with integrating with Jenkins. Like it knows where Jenkins puts logs. It knows where Jenkins, it knows how to communicate back to the web server to start, to say abort this job because something went wrong. And so there's some aspects of the system that are integrated with Jenkins. What?
Jenkins is one of the many CI systems we have. So companies tend to have some proprietary ones, commercial ones.
Okay.
These kind of CI things, web-based things coming up.
Okay.
And we also do GitLab, for example, right? Our GitLab CI is probably one of them used internally. So
Okay. Okay. That's good feedback. I appreciate that because I've wanted to kind of formalize, get kind of more formal information. Right now, we just built the system real quick. But to formalize what is the relationship between the scripted part of it and the continuous integration part would probably be useful so we could switch the front ends. And I would also like to be able to run tests on the command line, right? And so then there's another level of automation you can throw in there. So, yeah. It's just locking them on its own. Jenkins maintains the state of the board. It just knows when it's running its own test. So if something else is completely external to Jenkins is running something on the board, it could interfere with your results. But it's at least smart enough to hold off another test until it's done. But essentially, it's all serialized. So, yeah. The question is about running Fuego inside UML or Zen. Yeah, I don't know if we've thought about it. So I would say right now we don't have any plans. In terms of, so we're inside a container, and I don't know, I guess you can run a container inside a virtualized environment. In fact, that's probably why they were made. But anyway, but I don't know specifics about Zen or UML or any of those. So, the last question, I think. Yeah.
Is there any kind of support or abstraction for power measurements while you run your test?
There is not. So, again, Sony debug board includes power management instrumentation. So you could actually be measuring the power. So one of the things I want to do is I want to build into the Fuego system, if you happen to be using our debug board, you can be collecting power during the tests and run profiles, workload profiles or something like that. But there's nothing that would be specific to our board. There's nothing intrinsically in the framework that monitors power or has any of those concepts built in. Okay. Okay, last question.
So let's make sure that you are renaming the previous JTA.
Yes.
Not the book.
That's right.
Some people only drop the JTA, put the ADA guide, the JTA.
That's right. That's right. So this used to be called JTA. We are not forking the project. We are transitioning to a new name, which we think has better branding and is cooler, and you can do better logos. So anyway, thank you very much.